Hi everyone. So in this video I am going to discuss few questions from the chapter Alternating Current from the book Concept of Physics by H.C. Verma. So the first question is, find the time required for a 50 Hz alternating current to change its value from 0 to the RMS value. Okay. So the instantaneous value of current is given by I is equal to I naught sine omega t. Okay. Now the current changes from 0 to RMS value. Okay. So this I becomes IRMS. Okay. But what is IRMS? It is I naught by root 2. Okay. So that means I naught by root 2, it is equal to I naught sine omega t. Okay. So this I naught gets cancelled. So we have sine omega t is equal to 1 by root 2. Okay. So I can write sine omega t is equal to sine pi by 4. Okay. Or omega t is equal to pi by 4. Okay. Or that gives t is equal to pi by 4 omega. Okay. Now in the question it is given that the frequency is 50 Hertz. Okay. Now angular frequency omega, it is equal to twice pi times frequency. Okay. Frequency is 50 Hertz. So here we have to substitute twice pi times frequency. Okay. So if you substitute this, you will get t is equal to 1 by 400 second. T is equal to 1 by 400 second. So this is the answer. So in this time, the current changes its value from 0 to RMS value. So next is question number 2. The household supply of electricity is at 220 volt RMS value. Okay. Now see, here it is given in the question that the supply voltage is RMS voltage, but even if it is not given, you should always consider the supply or source voltage or current to be the RMS value. Okay, this is one thing. Another thing is, all measuring instrument, they gives the RMS reading. Okay, all ammeter, voltmeter, all these instruments gives RMS value. Okay, so you have the household supply of electricity is at 220 volt and 50 Hertz. Okay, find the peak voltage and the least possible time in which voltage can change from RMS value to 0. Okay, so first thing is, it is asked is peak voltage. Okay, now see, VRMS, it is equal to V naught by root 2. V naught is the peak voltage. So V naught is equal to root 2 times VRMS. Now this VRMS in the question, it is given as 220 volt. Okay, so that gives V naught is equal to 220 root 2 volt. 220 root 2 volt. Okay. Acha, now this is peak voltage. Next part is least possible time in which voltage can change from RMS value to 0. Okay. So again, this is similar to the previous question. The time taken to for this current to grow from 0 to RMS value, it is same as the current time taken for voltage to change from RMS to 0, because in both cases the frequency is 50 Hertz. In first question also the frequency is 50 Hertz. Okay, so for the second part, as in the previous question, question number 1, similar fashion you can proceed and you will get the answer as t is equal to 1 by 400 second. Next is question number 3. A bulb rated 60 watt at 220 volt is connected across a household supply of alternating voltage 220 volt. Calculate the maximum instantaneous current through the filament. Okay, maximum instantaneous current through the filament. Okay, so see, Vrms is given. Vrms is 220 volt. Okay, Vrms is 220 volt, and it is also given that, see, the Vrms means this source voltage. Okay, 220 volt. Now it is given that this is a 60 watt bulb. Okay, so IRMS is equal to power divided by Vrms. Okay, see, this is a circuit with purely resistance, no inductance, no capacitance. So we have already seen that power, average power, it is equal to Vrms IRMS cos phi. Now for purely resistive circuit, that is circuit with only resistance, no inductance, no capacitance, this term power factor, it is equal to +1, because phi, the phase difference between voltage and current, it is equal to 0 degree. Okay, so power is Vrms times IRMS. So IRMS equal to power divided by Vrms. Power is given to be 60 watt. Okay, and Vrms is 220 volt. Okay, so this is 0.27 ampere. 0.27 ampere. Now it is asked maximum instantaneous current. Okay, this is IRMS. This quantity is IRMS. Okay, we have to find I naught. Okay, so what is, how to find the value of I naught? I naught is equal to √2 times IRMS. Okay, IRMS is 0.27 ampere. So √2 into 0.27. So this is 0.38 ampere. So this is the maximum instantaneous current. Now next question, the peak power consumed by a resistive coil when connected to an AC source is 80 watt. Find the energy consumed by the coil in 100 seconds, which is many times larger than the time period of the source. Okay, find the energy consumed. Next question we have, the peak power consumed by a resistive coil when connected to an AC source is 80 watt. Okay, so peak power, P naught, it is 80 watt. Find the energy consumed by the coil in 100 seconds, which is many times larger than the time period of the source. Okay, we are asked to find the energy consumed. This is peak power. Okay, now see, PRMS, it is ERMS multiplied by RMS, IRMS cos phi. Okay, now this is a purely resistive coil, so that means this cos phi term is 1. Cos phi term is 1. Okay, now ERMS, it is E naught by √2. IRMS is I naught by √2. Okay, so that is equal to E naught I naught divided by 2. But E naught into I naught, this is equal to peak power. Okay, so this is peak power divided by 2. So we have PRMS is equal to P naught by 2. Okay, so this is another important relation. Okay, so this is relation between RMS power and peak power. RMS power and peak power. Okay, so peak power is 80 watt. So that gives PRMS is equal to 80 divided by 2. So that is 40 watt. So 40 watt is the RMS power. Okay, we are asked to find the energy consumed. Okay, so since we have the information about the power consumed, so what will be the energy consumed? So energy consumed, it will be equal to PRMS multiplied by time. Time is 100 seconds. So 40 watt into 100 second. So that is equal to 4000 joule, or you can write 4 kilojoule. Okay, so 4 kilojoule is the answer.